Hi class, so in this video I'm going to give you a quick little preview to the formula of an ionic compound lab, which I will shorten to FIC, and you can use this video to help you do the pre-lab questions. And I know this has been challenging because it requires you to have some knowledge from the previous semester. So firstly, you're going to know what an ionic compound is, and we're looking at the pre-lab area, the background section, to be able to understand the pre-lab questions. So an ionic compound is composed of ions, or atoms or groups of atoms that have a charge. And one important thing to know is that there's no net or overall charge, so the charge is going to be balanced. There's a term called an empirical formula, which is the smallest whole number ratio of each type of ions. For example, in magnesium chloride, the ratio is 1 magnesium to 2 chlorines. That's why you get MgCl2 as the formula. It's called a formula unit. But the overall charge on the compound is always 0. The reason this is because Mg has a 2+ charge and chlorine has a 1- charge, right? If you added these together, you would get a +1. And compounds are unstable when they're anything except a 0 charge. So you really need 2 of these. And when you have 2 of those, you have 2 positives and 2 negatives, and you get 0 from that. So that's why there are 2 chlorines in magnesium chloride. Okay? And remember from last semester, the way we did this is we did a little shortcut that I called crisscross. You take the charge on the first atom, on the cation, and put it as the subscript on the second atom. You take the charge on the anion, there's a 1 here that's not written, and you put it as the subscript for the other one, for the cation, and you get that formula right there, magnesium chloride, MgCl2. If you keep reading, you see that there are some ions of a charge group of covalently bonded atoms. These are called polyatomic ions. And I gave you a list of these last semester, but if you need another one, just let me know. And calcium, so they give an example here. Calcium is 2+, and NO3 is 1-. So you can crisscross these as well. Ca2+, NO3, 1-. You take the 2 and you crisscross it to the bottom, and you take the 1 that's in the charge and crisscross it to the bottom of the calcium, and you get CaNO3, 2. Calcium nitrate, there's 2 nitrates. The reason is because when you multiply this charge right up here by 2, you get -2, and this one is already +2. So together you get a charge of 0, which is very stable for any compound. So the empirical formula for calcium nitrate is shown right here, and the ratio would be 1 to 2. And that would balance the positive and the negative charges. In the background part of the lab, it talks about ionic compounds can be prepared by precipitation reactions. Now, one way you know that chemical reactions happen is when a precipitate forms. In this lab, you're going to take 2 clear liquids, and one thing that's going to be produced is a solid. And there's going to be a liquid left over too. But this solid is called a precipitate. And often precipitate is shortened to PPT. So when 2 ionic compounds are combined, they can rearrange to form new ionic compounds that are insoluble in water. Remember, we learned insoluble means does not dissolve. And this reaction shows an example of 2 ionic compounds added to each other. We have BaCl2 and Na2SO4. And now they switch partners. Notice, the Ba is the cation, right? It's +2 is in the second group. The sulfate is the anion, that's on the polyatomic ion list. That's -2. Notice that that formula is BaSO4 because when you crisscross the charges of Ba2 plus and SO4 2 minus, these numbers crisscross to the bottom, but then remember, after crisscross you got to reduce, so you get BaSO4. That's how you get that formula right there. And then you do the same thing for Na. There's Na is the cation, Cl is the anion, and you combine them together. And so we crisscross the charges. Na is in group 1, so it's +1. Chlorine is in group 7, so it's -1. You crisscross them, and since they're both 1s, the formula is NaCl. It's not Na2Cl2, it's NaCl. We won't worry about what that 2 means right now. We'll learn that later. So one thing we're learning is that this is soluble in water. And how's that shown? Well, it says AQ next to it. We know from experimentation that sodium chloride is dissolved in water. So that's what the AQ means, dissolved in water. That means the other one has to be the precipitate, if a precipitate forms, and that's BaSO4. So, knowing this much, you should be able to answer the pre-lab questions for the formula of a compounds lab. Try your best and show me in class at your earliest opportunity. Thanks.